Yes. So our approach was to first do a survey with all the root server operators and ask them about what software do you use to serve the root and what operating system do you use and how do you configure your operating system and how do you configure the software. So not all of this is public, but much of it is public. So I can say that a large part of the root is served by open source software.
You're listening to Ping, a podcast by APNIC discussing all things related to measuring the internet. I'm your host, George Michelson. This time on Ping, I'm talking to Willem Toorop from NLNet Labs. Willem has been on Ping before, talking about kernel-level packet filtering methods, but this time he's exploring a measurement activity about the names of the DNS root servers. Root name servers are part of the global DNS system, and they provide basic bootstrapping for every other DNS resolver and authoritative name server worldwide. They also handle query load relating to the global DNS system all day and every day. There are 13 distinctly named root servers, each one identified by a letter from A to M. There are, in fact, thousands of machines providing this service behind each letter. The letters are named under a fully qualified domain name, a special zone, rootservers.net. This was instantiated in 1995. It's delegated as normal under the .net zone, which in turn delegates from the root .zone. So there's a kind of circular dependency risk that to find a root server, you appear to need to know about the delegation of .net to find rootservers.net to find the given server. This is resolved by the contents of an initial priming response. This response provides the additional glue information to seed direct knowledge of how to find each of these named root servers as is, without all the intermediate logic of the circular dependency. Something that has to be just understood for now is that this glue is inherently not signed in DNSSEC. It's insecure. The priming response is very carefully curated for both its size and the content. A document published in 2017 by the ICANN Root Server System Advisory Committee, or RSSAC, explored the impact of applying DNSSEC over this domain, which in turn would add DNSSEC signatures to the priming response and impact a goal of keeping this a small 512-byte backwards compatible form. This would continue to work on all legacy systems worldwide. So changing the naming model of the roots has impact on something we want to protect. Nothing happens quickly in DNS evolution, and this naming question has now been under consideration for over a decade. Willem and his colleagues at NLNet Labs produced 2 reports with collaborators at SIDN Labs, also located in the Netherlands. The reports reflect on the candidate naming schemes, application of DNSSEC, and the impact on the bootstrap fetch.
Willem, welcome back to Ping.
Thank you, George.
So people may not know that Willem has been on Ping before, talking about some work that he did putting packet filtering and processing logic into the Linux kernel. This time, we're going to be talking a little higher up the food chain, a little bit more in sort of layer 9 space around decisions of what we do in the DNS, aren't we?
Yes. And at the same time, it's also very lower level because it's about the root.
So it has a little bit of both the structural behaviors of the DNS and this question, how do we proceed doing things we do in the DNS? So to lay the tracks a little, could you tell us a little bit about why you're doing this report? Who asked for you to do this analysis?
Yes, so this is about indeed 2 reports I did as part of a consortium together with SIDN Labs. So there are a few people from NLNet Labs and a few people from SIDN Labs. So me, Benno and Jorgos from NLNet Labs and Moritz and Marco from SIDN Labs. And this is in response to community requests. So there's the root server System Advisory Committee, the RSSAC, and they wrote a report 28, which is about different naming schemes for the root.
Yeah.
To assess if the root, as it is currently designed, has the most optimal or the best naming scheme.
Yeah. So that is an ICANN grouped committee. That's a review body that kind of discusses aspects of the root server system as a whole.
Yes.
But you said there were two.
Yes. The other committee is the Root Zone Evolution Review Committee, and they review potential changes to the root and can also do suggestions.
Yeah.
For example, that Zone MD is now part of the root. That came from
Yeah, and they are also ICANN driven, but
Yes.
there is quite a range of participation in this. RSSAC is quite a large inclusive body. There's a large number of people. The RSSAC is a little smaller, perhaps?
Yeah, I'm not sure how many people, but it's all representatives from different organizations.
So we might need to follow a different path in laying the tracks. When we talk about the DNS, there's the part which is to do with what is actually said. That is about contents of zones, things like Zone MD.
Yeah.
And there's the part which is who is saying it.
Yes.
And the work you're doing, I feel, is kind of in a weird intersection, because in order to say who is saying it, you have to actually put some data into the DNS.
Yes.
So it's kind of self-reflecting that this list of entities that tell you things, the name servers, the NS records, have to be in zones. And we are right up at the apex of this system, the imaginary dot that is on the end of every single name.
Indeed.
There has to be a list of things that serve them, and they are called the root servers.
Yes.
Every root server has a name.
Yeah. Well, those are called root server identifiers.
Okay.
A till M.
Right. And those names have to exist in the global DNS.
Yeah.
And there's this operation that we call the priming function, where you try to determine how many of these there are and where they are and how you could communicate with them, which demands that you receive information about a zone and the structure of those names. Now, this study is about aspects of the structure of those names, isn't it?
It's indeed about bootstrapping the whole DNS and the priming query.
What was the primary concern that led people to wanting to ask some questions?
I think the RSSAC 28 report, which is about different naming schemes, is just part of the job of this root server system advisory committee to periodically revisit if everything is just as but the best current state of practice, so to say.
Right.
So they need to re-evaluate if there could have been a better naming scheme for the root servers.
So this naming scheme, it kind of has a consequence of the shape of the smallest packet you can send in the UDP DNS, doesn't it? There's a boundary that says if you try to encode this priming data in more than the length of this base packet, you've incurred protocol cost that has to cope with bridging into multiple packets.
Yes. Yes, so the size of the priming query is the motivation for the current naming scheme, which came from Paul Vixie.
Yeah, he did the basic work quite a few decades ago now.
Indeed, in 94, I believe.
Yeah, and the behavior here, again, this is something that we don't often talk about in the DNS. When you look at a packet that has a DNS request with a fully qualified domain name, you don't necessarily see the literal string of ASCII characters that are the name. This thing called label compression is done on the name, isn't it?
Yes.
What does that really look like in practice?
In practice, because all the root name servers now have a very similar name, in the current naming scheme, they have the identifier, which is a letter from A to M.
Yeah.
So there are 13 identifiers.
Yeah.
And then there's a dot and the remainder is root-servers net.
So if we consider each of these names as instances of labels in a domain system, they have a unique component, and there are 13 unique values. They then share two common components, root-servers as an intermediate and .NET. And under label compression, each of these things has to appear once, but then the subsequent reuses can say, just like that one. It's classic compression technique of only sending the minimum amount and sending a linkage to say that one.
Indeed. So the long part is compressed into 2 bytes.
2 bytes.
Yeah.
And then having 13 of these means that you have acquired a cost of 13 of the unique, 13 pointers back to the long string and 13 back to the other shorter string.
Because the glue, the address records, are also in there. So,
glue. Glue, this wonderful thing that you're told a label, but you're then given hints about what the label is, because otherwise you're coming back and asking a question again, and in priming, you don't know who to ask yet. So glue is additional data, and it's about addresses.
Indeed. So instead of having 13 times 3, the root service.net only have root service.net once, and all the other 3 times 13 minus 1 instances just refer back to that.
And then additionally, glue is added. And this glue has to be for both IPv4 and IPv6, doesn't it? So this then grows the packet, and you have all the other DNS protocol components, and we arrive at the boundary size that is, it's somewhere around 512, 570 bytes. There's some magic number quality. It's just the state of the world. And Paul designed this naming scheme to get the most possible benefit that he could. But this was designed before DNSSEC. And this was designed before IPv6.
Indeed.
And these names aren't necessarily either in a subzone under the root or necessarily directly in the root.
Indeed.
There are decisions to be made.
So in the current naming scheme, it's indeed below the .NET zone. So there's a strange circular dependency, especially if you think about DNSSEC. Validating
the trust in the path where you are told to go and ask somewhere else. So this inquiry is kind of the statutory need. Let's check if we're doing this right.
Indeed.
And it's an opportunity for you to review questions like, how does this work under DNSSEC? What would it look like if it changed?
Indeed.
This was the nature of the work you were doing?
Indeed. So the original RSSAC 28 report proposed 6 different naming schemes.
6?
Yes.
I think 3 would have been enough.
And one of the recommendations in this report was was basically to request a follow-up study to see how resolvers would respond to those naming schemes. And that's what we've done.
So can you give us a brief flavor of the differences between the 6 schemes?
Yes. So it's actually 5 new schemes, because the first scheme is the current scheme.
And there's always that option, do nothing. So just leave alone. Let's measure what we've got.
That's a very good option, actually.
Good option.
A good option. The second scheme is the current scheme, but then DNSSEC signed. So you have to know that in the current scheme, the NS resource record set is already DNSSEC signed. Right, the response to the priming query. But root service.net, that whole zone, is not DNSSEC signed.
So there is this thing that you would call loss of secure entry point, SCP. There's no SCP over that namespace, which means you can't currently perform DNSSEC validation.
That is right. So the proposal, indeed, for the addresses of the root service.net zone, this is not possible. There's no DNSSEC validation of those addresses.
Right. And so a change here would necessitate either signing over the zone or moving them into a zone that is already signed.
Other naming scheme proposals for root servers are all DNSSEC signed, by the way.
Right, so all of the other 5 alternates were signed, but they achieved the outcome with different structural forms.
Yes.
Some were bigger, some were smaller.
Yes, definitely. Yeah, the different naming schemes have different impact on the size of the priming query, but it's also affected by the authoritative name servers that serve them, and also by the query parameters of the resolvers. So yeah, but maybe I'll go through the list of the schemes. So the second one is current scheme, but DNSSEC signed. The third one is just having all the names within the root zone itself.
Yep.
So there's no delegation in between.
Which would permit signing because the root zone is signed.
Absolutely, yes. And also, which would automatically mean that it would be signed indeed.
Yep.
But maintaining the root server identifier. So each identifier has its own name.
Yep.
So either just a single letter for the addresser or single letter dot root servers.
So something which needs to be clear here is that when you look at a fully qualified domain name, these dots do not necessarily mean is a different zone. You can embed a name in a zone with a dot in it. And so these things are like potential zone boundaries. They're not necessarily a real delegation point.
Yes.
And one of the proposals was to embed strings in the root zone that included the dot.
Yeah. And then all root name server addresses would be authoritative within the root zone, and so automatically would get signatures. So the fourth proposal is a shared delegated top-level domain, root servers. So basically just cutting out the .NET at the end.
Yeah.
So root servers, the root servers would get their own top-level domain.
I might come back to that, but keep going.
Then the fifth one is each root server identifier, his or her own TLD. So just the letter A would delegate to VeriSign, which is the root server operator that serves.
So instead of having a unifying quality, which has delivered label compression, it would explicitly recognize the independence of the entities providing it.
Yes.
And in some senses, that is a different kind of resilience, isn't it? It prevents single point failure in naming because other parties are using other name forms. So although I'm sort of thinking, that sounds more costly, it had the potential to be more resilient.
Okay. Is it okay if I jump ahead already to the conclusion a little bit already?
Yeah, okay. Yeah. I mean, people might cut out listening early, but that's okay.
So this one, the fourth, with a TLD or a to-label, but a delegation for each root server identifier, is the single scheme that did not have any problems with any of the resolvers.
Wow, that is very interesting.
It was very surprising.
So you have one more to catalog, either one or two more to catalog.
Yeah, the last one is a single shared label for all the operators. So just one name, root servers, and then that one name has all the addresses, right?
Yeah.
So now the root server identifiers don't have their
I remember this being raised at one of the Dallas IETFs as a potential model for naming, and it kind of invokes something in anycast, that the proper number of things in a world of anycast is possibly one.
Yeah.
And this goes directly to that. Why do we have to identify uniquely? And one more after that?
No, that's the sixth one. But that's, if I can skip ahead again, because this one has also a surprising but outcome, is that there's a variant on that if that single label for all the operators would be just the dot, like no label, then that's the only one which can guarantee to the resolver that all the glue in the additional section is authoritative.
Oh, wow.
Yeah.
Choices. So, how did you go about testing these 6 propositions? What was your basis of measurement that would give you information?
Yes. So, our approach was to first do a survey with all the root server operators and ask them about what software do you use to serve the root, and what operating system do you use, and how do you configure your operating system, and how do you configure the software. So not all of this is public.
No.
But much of it is public. So I can say that a large part of the root is served by open source software.
Yeah, which in itself is highly beneficial and something I personally enjoy. I think this is creditable.
Yeah, indeed. So for the open source authoritative software, bind NSD, not DNS, is the popular, so to say, or that's
so we have a diverse
used.
Community of platforms and of software providing the prime protocol function.
Yes.
We are less exposed to risks of single source than we might think in this space.
And also, very important, diversity of organizations that serve the root, which came apparent during this conference, actually, because I noticed something very odd. This is a little bit of sidetrack, but I think it's worth mentioning that G-root and H-root, which are the two US military ones, were not reachable from the...
So because we are conducting this interview in the IETF meeting being held in Shenzhen, we are necessarily behind the boundaries of state control, which affect visibility of services. And without objectifying either side in this, because there are two parties in the delivery of service.
That's right.
It's just an observation. The two entities that have that vesting of authority are not visible in this community. It could be a domestic matter here. It could be a matter for the providers in the home economy. It's just the state we see.
That's right. It's very hard to detect which side was the blocking side.
I don't particularly feel we need to talk about that here, but it's an interesting observation, Willem.
Yeah, definitely. So it's good that root is served by diversity.
So you did a survey of the operators to establish the basis of delivery. Was this so that you could model behavior in a lab, or was it so you could understand when you performed tests in the real space? How did this then progress?
So all the tests were performed in a lab environment.
Right.
And software for that was originally designed by Paul Hofman, actually.
Really?
At ICANN.
Another member of our community who has done much work in this space.
Yeah, indeed. It's the Resolve testbed, so you can find it in the ICANN GitHub repository. We built extensively, or we made a huge contribution, I think,
There's been other deliveries from the Dutch DNS research community in this space. SIDN have done work building DNSSEC testbeds to provide visible tests against crypto architectures and algorithms. And I think it's the kind of space that bodies like NLNet Labs and SIDN are absolutely beautifully designed to address. Take sources from other people, build and invest, make something and use it to deliver a public outcome. It's lovely.
Thank you.
It's really lovely. So you went out, you constructed a lab, you modeled the platforms you saw visibly providing root service, and then you took these 6 name forms and you applied them to this environment.
Maybe it's also worth mentioning that there are also 2 commercial authoritative name servers used by the root, which is the Atlas name server used by VeriSign that serve A and J, and Cloudflare, which is serving F. And so what we needed for our tests is how this software would respond to the priming query. For the different parameters.
But it would be difficult to bring that into a lab. Did you enter into an NDA that gave you exposure to their software?
No, but we managed to, with someone that had access to the Atlas platform and someone that had access to the Cloudflare platform, for them to do priming queries for all the different naming schemes, with all the different resolver parameters.
So some component of your results were from a test bed and some were from live application with a partnership that allowed comparable results.
Indeed. And then we created simulating name servers within the testbed that would simulate
you
Atlas.
did a clean room implementation of their behaviors to match the observations that were seen in the real world.
Yeah.
That is very interesting.
Yeah, with a bit of an NLnet Lab software called LDNS TestNS.
Right.
Which is able to, on a very low level, simulate responses to certain queries.
So in the real world, a system like Cloudflare's or like VeriSign's is handling millions of queries per unit time. It is absolutely saturated with load, and it exists in an anycast cloud. In a lab environment, you're not actually testing necessarily what happens when 1 million people ask. You're asking the fate of a single bootstrap. What is its transit through the protocol state? So you only needed to respect the protocol behavior. You didn't need to service 20 million queries.
That's right. We needed to test the diversity of responses and not the, if the identifiers would be able to, handle the load of queries.
How long did this take to run?
Oh, this was a big effort, really. So because, there are so many different parameters that we tested.
Well, there are the 6 different naming schemes, but then there are qualities within the priming behavior, each one of which had to be measured and assessed. So it's a large multi-dimensional matrix of behavior.
That's right. Yeah. There was a lot of result processing going on. And if you really want to know the extent of the amount of data that we processed, reading the actual report.
We'll maybe put a conclusion in our blog that goes with the podcast pointing at this. So you've given us 2 reveals of the final outcome, but I'm interested, did you find any fatal one-way streets in some of the candidate name models in the software platform that you are testing?
Yes, we did. But first, I like to point out, just because I think it's important, that for this study, it was important to look at the open source resolver software, because the assumption is that those popular public resolvers or large resolvers, if there's anything problematic with a certain naming scheme, it's possible to reach out to them and ask them to change their behavior.
Yeah.
But with all the different ISPs on the internet that use the open source resolver software, this is not possible.
No.
Therefore.
And so the people who ship that software, which includes NLnet, because you are now responsible for Unbound, which has a large surface of visibility globally, you have in some sense acquired an obligation, a burden in this. If you found a problem, you would be involved in writing mitigating behaviors.
That is true, but the assumption is also that a large part of the internet will just keep running old versions
forever.
So we also tested really old versions of bind, not resolver, power DNS.
Bind back to bind 4.
And Unbound. No. We didn't get this to work, but...
that's a little too old. Given it doesn't do DNSSEC, that wouldn't be there.
Yeah.
So, what was the nature of a test? What would a typical test look like?
I think the typical test would be just 2 test queries. Yeah, I'm certain we did this. And to start up the resolver, so to say, because those resolvers have different ways they do priming. And we were primarily interested in the priming query, because that involves the names of the root servers.
Yeah.
And a second query to see if everything succeeded and what the current state.
So if the resolvers had acquired state and you could demonstrate that state was functionally informing subsequent behavior.
Yes.
So DNS, the protocol, I mean, it's beautifully simple. It's UDP for most people, send query, get response. But it has parameters. Yes. There are qualities inside the DNS packet that inform subsequent behavior, like please validate, turn on sending me associated data, only give me authoritative answers.
Yeah.
Tell me if I have to move up to TCP. Tell me if you want to do a secure identity exchange so that I can't do DOS attacks or fake packets. Were you testing those parameters as well?
All of them.
So this is 6 naming schemes, 4 or 5 open source and 2 modeled private implementations, resolver versions back to the dinosaurs, and all these parameters. This is a big multi-dimensional test.
Yes, it was very multi-dimensional, leading to a lot of data to process. But it was sort of limited in the sense that we looked first perhaps to look at the different ways of query parameters that resolvers use. We looked at all the queries of DITL and inventorized all the different query parameters.
So this is taking a large public data set that represents the surface of queries seen typically at the roots, but in other nodal parts of DNS as well, and using that to inform the nature of queries that you present to this system, having been primed in this behavior. People may not realize that there's a subsequent behavior after priming where, if you like, resolvers taste test how quickly they're serviced by their back. And so different qualities in the behavior of the root system alter the dynamics of choices made in the resolver space. Applying real query load actually helps model, but what's the consequence in the longer term? It's a nice way of testing things. Did you do a random sample from that? Were you taking like a 1 in 10,000 packet sample? Or?
No, we just took the whole of DITL data, which is so it's
the whole of the day's collection.
Yes. Yes. But this was just to inventorize the different query parameters.
Right.
Because what we noticed...
So you sampled from that the selection of parameter settings so that you would normalize, if you see this set, you tend not to see that set.
Yes.
Let's query this without that. That's
Indeed.
The normal profile.
Indeed. And by doing that, we discovered that using all those different query parameters, which is, I don't know, millions, the authoritative responses to priming could be divided into 8 different ways or in 8 different groups. And within each group, I think 4 different ways, depending on 4 different groups of query parameters.
So you managed to bring the number in this giant phase space of properties down to a more ordered subset of data.
Yes.
I think people are going to want to read the report to understand. If we stay at the headline level, which of these 6 naming models did you effectively knock out? Were there any you said this just is too risky?
Yeah, there was one, which unfortunately is the top level domain shared with, so cutting out .NET basically. Top-level domain.
This just introduced too many behavior changes. It had higher risk overall.
This stopped some of the resolvers of doing resolution at all, which is a showstopper for the whole naming scheme, because those resolvers will be on the internet forever, right?
So there's a clear, we can't do that.
Yeah.
Maintaining the current naming form, you presumably demonstrated, has no particular downside.
Well, that was also surprising. Indeed, the current naming scheme also has issues.
Really?
Yes. And thanks to our report, so Dwayne has this ongoing, or has this topic on which he presented.
Dwayne Vessels, which is also the root zone maintainer at VeriSign. Yes.
So he's responsible for maintaining the root zone. Notice that so in the past, JRoot has changed its addresses, and there are still many, many resolvers that send queries to the old addresses.
Yes.
That have not picked up the new address, not from priming.
I had a conversation with Dave Plonker, who was formerly at the University of Wisconsin, and he did a wonderful study of a DDoS against NTP servers many years ago now, at least 2 decades ago. He recently revisited, they're still seeing 20,000 unique addresses bombing that address family for NTP 20 years later. So it's not just DNS that has a long tail of this kind of behavior.
Yeah.
Some things are forever.
Yes. But so for Dwayne, this was a mystery until we wrote this report, because we identified the software that fails priming or fails to learn the new addresses when the new naming scheme it learns through priming is not altered. So it sees the names have stayed the same, and then it wrongly assumes the addresses will be the same as well.
And were you to rename into one of the new schemes, would this heal itself?
Yes. Absolutely.
So we now actually have, from a measurement activity, a strong signal of benefit for deliberately making a choice to a new form of naming.
And Dwayne also tested this more severely, and he presented this during the last DNS org.
Oh, we
and
might want to look at that as well in the blog. That sounds like an interesting outcome. So, did you arrive at a recommendation?
We wouldn't go as far as to make recommendations from this report, but we had one naming scheme that did not have issues, which is each identifier getting its own delegation from the root.
Yes.
But the other schemes, so there's one that is really problematic, which is a single delegation for all the identifiers.
Which surprises me. I had expected this to be a naturally efficient and functional form, but the outcome is...
It's very surprising, but we are really, really certain because we tested over and over again.
Yeah, and you sometimes have to accept the favorite model you hold in your heart is just not the one that survives the process.
Yeah, unfortunately. Yeah.
So that one's out. The current scheme has a weakness that is about historical behavior, and you have observed at least some of the other 4 are capable of healing this behavior. Yeah. One of them is a delegation in the root to each of the entities.
Yeah.
And the other one is the invisible naming.
It's the everything authoritative in the root.
Yes.
So this has problems because if the signatures are also added to the additional section,
yes,
then the priming query will become huge for some of those naming schemes.
So we come up to the primary problem of failing to cope if you are in an older generational behavior expecting a single packet response.
Yeah.
You may enter a problem. However, they are less likely to request DNSSEC. So for the really old case, fine. But for the intermediate case that still has dependencies but needs DNSSEC, you're now it's a multi-packet response. Does this uplift to TCP?
Yeah, we also looked into if resolvers were able to fall back to TCP and if they would, but it still showed some problems. But there's another notion. But you can see that if each root server identifier would get its own name and all the signatures for the addresses would also be included in the additional section, that this will become a very large packet, right? Like more than 4K actually.
Wow.
Yeah. So the 6th scheme, for which the root server identifiers don't have their own name, has much smaller packets because it only needs 2 signatures in the additional section, one for all the IPv4 addresses and one for all the IPv6 addresses.
So we now come to that delicious moment in a podcast that is trying to be about measurement and trying to be about technology in its purest sense, and we arrive at layer 9. Politics.
Yes.
Do you think this is a tenable answer for both the root operations community and ICANN in its duty of care? Because this sounds like it has a component of decision that not everyone might be comfortable with.
Yes, but there's an additional bit of information that I have to give for a well-considered choice in this respect, because as long as the names for the root server identifiers or for all the root is below the root, as long as there's a label which is not the root itself doing this, then there is a possibility that there would have been a delegation to those names, right?
Yeah.
You can see that?
Yes.
And for that very reason, a resolver cannot assume that the signatures will be there, because it could have been below a delegation.
Sure, this putative dot could have invoked a zone cut and could have invoked the necessity of a glue binding to tell you how to follow the chain.
Yes, and therefore any possible intermediary can just take out those signatures without being punished for it, so to say, without...
Right.
So they don't really add security to the priming query.
Oh,
Isn't that
wow.
Yeah.
Wow. Yeah. So we've come to the hard point that security after the fact is an extremely hard thing to do.
Yes. And so one of the possibilities is also to change the authoritative behavior, right? Because also this open source name server software, which is used by the root servers, can be adopted to just not include those signatures, even though it was authoritatively present within the root. And then those schemes are also do not cause any problem.
Willem, I think this is fascinating. It feels like you've conducted a really strong test, a measurement in system with an analog, a model, and with clean room implementations of proprietary behavior with real-world informed data. And you've been able to do some categorizing of choices faced in the community. I think this is an amazing outcome. But I have a feeling we're going to want to talk to you again about some of the subsequent consequences of this discussion.
Yes.
So hopefully we can have you back another time to talk about that. Thank you. This has been fascinating.
Absolutely. And thank you for having me. And I would love to come back and indeed talk about the consequences of this research. Yeah. Thanks.
If you've got a story or research to share here on Ping, why not get in contact by email to ping@apnic.net or via the APNIC social media channels. Also, remember the measurement at apnic.net mailing list on Orbit is there to discuss and share relevant collaborative opportunities, grants and funding opportunities, jobs and graduate placings, or to seek feedback from the community on your own measurement projects. Be sure to check out the APNIC website for all your resource and community needs. Until next time,